Hi everybody and welcome. Today we're going to start off by actually talking about Ohio Stadium. So our goal after watching today's video is to be able to take word problems and convert them and solve systems of equations. So to restate that more simply, we're going to be solving systems of equations word problems today. So a very common one that comes up, and they really like questions like this on standardized tests, is the idea of tiered seating. So you have a different price for different amounts of tickets, different levels of tickets. So for example, if you're way up in the nosebleeds, you're really far away from the field, you're probably in zone D with the yellows. If you are lucky enough to know somebody or just have really good tickets or good luck, you might be in the suite level if you're kind of like seated inside of those boxes. And then finally, we have closer seating, which is in zone B. And then the closest you're basically on the field seating is in zone A. So as you can imagine, different prices for each level of ticket. And a very common thing that might come up is, they might say something like 10,000 tickets were sold, and they won't give you full information. So maybe like 80 tickets were sold in zone B, and 5,000 tickets were sold in zone C, and using this information, figure out how much money Ohio State makes. So more or less what's happening is in a situation like that, they're introducing a lot of unknowns, and they're asking you based off of those unknowns to solve and basically solve for the unknowns. So tell me how many tickets were sold in each of the zones, and let us know how much money Ohio State makes off of the games. So in a situation like that, some things that you want to do first and foremost is make sure you're annotating. So we want to put down like the prices of each of these zones. We want to do that again for all of the zones. And again, if we're given that information, we put it there. And then the same thing for sales. So they're going to tell you like, maybe in zone A, not that many people can be there. So like 1,000 were sold in zone A. We don't know how much are sold in zone B, so we'll use X. We don't know how much is used in zone C. So we'll put a different variable. I got to change my color so you can actually see it. Maybe blue works. Maybe Y works there. And then they might give you a little bit more information to help you finish solving. So something like, zone D is nosebleeds, most common section, 6,000 there. And then the green press box, pretty small, so maybe only like 500 there. So based off of all this information they're giving you, you're seeing you have multiple unknowns. They are giving you quite a bit of information in the meantime, though, so it's your job today, after watching this video, to be able to take a situation like this where they spell out more information for you and to be able to solve it and calculate all of the missing pieces. And it gets harder with systems because there's a lot more missing pieces than before. Usually with equations and these word problems, you'd be like, solve for this one thing. But now a system, it's solve for, 2 or even more unknowns. So that's our kind of goal today, is to look at a situation like this with confidence. So the definition that we're going to use today, and it's not really a definition, it's kind of a concept, is having multiple unknowns. And the thing that helps me with this is that kind of remembering this principle that you need one equation per one unknown in order to solve. So basically what that's saying is that if you have 2 variables, you can't solve unless you have 2 equations. If you have 5 variables, you magically can't solve with 2 equations, you need 5. So a lot more information is needed if we have multiple variables. So if we have x plus y equals 7, and maybe a second equation that's like 2y equals 8, we have 2 equations, we have 2 unknowns, so that is solvable. If we have something else like x, y, and z, add together to get 18, and then they tell us that y equals 12, that's not enough, because we have 2 equations, but in this case we have 3 unknowns. So we won't be able to solve that. It's not possible. So when looking through word problems today, we kind of want to ground ourselves in that idea of if we're seeing multiple unknowns, we need to make sure that we're writing multiple equations, because if we don't have multiple equations, we're not going to be able to solve. So first, fully annotate. Grasping all of the information they give you is essential because we can't miss anything. Second, set up an equation with your unknowns and constants. So that's basically a fancy way of saying you're going to have some variables and you're going to have some numbers. Put them together, make them make sense together. And then finally, once you do all of that, solve your system of equations. So your goal is to, if you have two unknowns, to make two equations, and then you'll be able to solve those two equations. All right, so let's take a look at an example word problem. We'll start annotating together, and then you'll be able to practice with the remaining one. So a store sells two types of flowers, daisies and tulips. So you purchase a total of 13 flowers for $98. Okay. Daisies cost 8, tulips cost 7. How much of each type do you purchase? So each type, that's telling us we have two unknowns. So if we have daisies that cost $8 and tulips that cost $7, and our total spent is 98, that would be an equation. And in the past, that might have been an equation that we finished with. We're like, okay, we can try to graph this or do something, but we're seeing here, we have two unknowns, daisies and tulips. So do we have any more information? Let's take a look back. Purchase a total of 13 flowers. Well, I didn't include 13 anywhere, so it looks like maybe I have more information for a second equation. So daisies plus tulips equals 13. So again, if I combine the number of daisies I buy and I combine the number of tulips I buy, I need to have 13. And then secondly, if I multiply each by its cost, it needs to add up to $98. So these are my two equations. I have two unknowns, and there's a system. I just set it up. Now we can go ahead and solve it. I see something like this, and I would probably use substitution personally, but elimination works as well. So I'll let you solve this system however way you want, but the main purpose of today and our goal is to be able to go through to annotate and to write two equations based off of that. All right, so let's annotate our next one, and then you'll have the opportunity to set it up and to solve both of these. So again, to be clear, please solve that top one still. Two trains leave a station. One is north and one is south. After 3 hours, they are 357 miles apart. One train is traveling 5 miles an hour faster than the other, and they want to know the speed of each of those trains. So we are looking for those two variables, the speed for each of those trains. So we're going to try to use the information that they gave us, 3 hours, 357 miles apart, put those together to create another situation just like up top, where we're, again, making a system with two equations. So that's your job. So come up with two equations to come together, and then eventually, once you have those put together, to solve. All right, so again, key concepts from today is we're not learning any new ways to solve, we're just translating our knowledge that we already have to word problems, and the biggest thing with word problems is careful reading and careful annotation. So as always, any questions, let me know. I will see you all in class very soon, and thanks.